All right, I'm glad you guys can hear me. We're going to go ahead and we're going to resume where we left off at in chapter 9. Okay. And so we spoke about interface costs, port costs via the IEEE standard, right? And so let's talk about some of the details that are specific to just spanning tree, right? Um, what does spanning tree activity look like when the network remains stable? Let's take a look at that, right? So what I'm going to do, right, in my lab, I'm going to go ahead and do a packet capture, right? It has that ability, and I'm going to do a packet capture on the interface gigabit 0/0 that's pointing towards switch 2. Let's see what happens here. Okay, let's pull that up, right? Um, EvenG has like a Docker Wireshark feature, okay, where we can go ahead and basically emulate a packet capture, right? So it's pretty cool. If you guys ever consider, EvenG, this is one of the features. But let's take a look at what it looks like, right, when a network is stable, right? So a spanning tree root switch sends a hello BPDU, right, every 2 seconds, right, 200 milliseconds, right? Um, 202,000 milliseconds, one of the two. But essentially every 2 seconds by default, right? Each non-root switch forwards the hellos on all designated ports. Okay, so we'll look at that in a second, right? Um, right? But here's the thing, right? When those designated switches are forwarding those hello BPDs, right? Each switch sets the root cost to the local switch's calculated root cost, right? And that switch is going to go ahead and also sets the sender's bridge ID, right, to its own. It's going to set that value to its own. Okay. Let me go ahead and click on a random spanning tree, right? And so here's what I mean, right? When we're looking at the root switch now, which is switch 1, right? It's sending its own bridge ID in that spanning tree frame, right? Right. And we call it frame because we're talking about layer 2. And so looking at this, right, it has its own, right, its own MAC address, right? Master MAC address, and of course, it's here as well, right? And of course, I only know that this is the correct MAC address for switch 2 without getting into the CLI because, of course, I looked at it before, right? So it's going to send that, right? And we're going to look at the designated switch in a second, right? Assuming, right, the default hello timer of 2 seconds on the root switch, right? Each switch will forward the receive and change hellos out of all designated ports, right? Because on the root switch, all of the ports are designated, right? It's going to continue to send out those hellos, right? And then forward them to, of course, all switches that are connected to it, right? Every 2 seconds. It's going to continue to send it every 2 seconds, every 2 seconds, every 2 seconds, right? So what does that process look like? Now, this is a key topic that you guys need to understand, right? Where's my pencil? There we go. Right? That switch forwarding always those hellos, forwarding those hello frames every 2 seconds. So the root creates and sends the hello BPDU, right? With a root cost of 0 out of all of its working interfaces. Okay? And again, interfaces that are in a forwarding state. Okay? The non-root switches we're talking about right here, right? The non-root switches receive the hellos on their root ports, right? After changing the hello to list their own bridge ID, has the sender's bridge ID, and listing that switch's root cost, right? And then that's right, this switch, and we're talking about switch 2, that switch is then going to say, hey, I'm going to forward that hello out of all of my designated ports. Boom. Right? Because in this topology that we looked at before, right, this port is blocked. Okay. And so, as you can tell, every 2 seconds, okay, every 2 seconds, this is going to happen until a topology change happens, right? Let's say a switch fails, right? It fails to receive a hello, right? it notices a problem is happening in the network, right? And so that's where the max age comes in, and those max once the max age, it ceases to receive those hellos, right? The switch automatically reacts to go ahead and start manipulating the spanning tree topology or going through convergence as we talked about before, right? And so let's go ahead and go to that non-root switch, right? Let's pull that up, right? Um, what does failure look like, right? And why are, and this brings me to a good point. Why are, right? Why is it important to understand that the switch is going to react whenever it doesn't receive a hello BPDU? Well, right? There always is a process for everything. Things don't just fail, things don't just, converge or just work. Has a CCNA candidate and has a future network engineer, right? You guys need to understand how every little thing works, right? Everything isn't just programmed, okay? Um, so we were talking about the hellos, right? Not, it's forwarded out of the root switch every 2 seconds. The non-root switches are forwarding it out of all their designated ports every 2 seconds. But what happens when we have a failure, right? Do we have any mechanism that controls that? Yes, we do, right? So we have what we call spanning tree timers that manage spanning tree convergence. Okay. So spanning tree convergence, right? That process, it requires the use of 3 timers. Okay. Right. And so all of these timers are dictated by the root switch, right? Because of course, before that election process of choosing a root switch and root ports, what have you, they have to agree on the same timers, right? So if that switch that's a superior, quote unquote, right, within the topology, they need to make sure they have the same timers. But what timers manage spanning tree convergence? Well, we have the hello timer, right? And that default timer is 2 seconds, right? And that's the time period between hellos that are created on the root. That's it, right? And how can you confirm that on a switch, right? You can confirm it right here, okay? You do a show spanning tree and you can see the hello timer, right? You'll see the hello timer for your switch, right? Which of course it shows here the bridge ID, but also for the root, okay? It shows you those timers here as well, okay? Now, the other timer that manages spanning tree convergence is your max age timer, okay? What is the max age timer for, right? The max age timer for is how long any switch should wait after ceasing to hear hellos, so not hearing the hellos, before trying to change the spanning tree topology. Okay? In the default value of that, right? Timer value of that is 10 times the hello. Okay? All right. I want you guys to understand that, right? By default, the max age timer is 10 times the hello timer, right? So if the timer for the hello is 2 times 10, 20. Okay. All right. So now that we got that, right? The last timer that manages spanning tree convergence is the forward delay. What is that, right? And so the forward delay is the delay that affects the process that occurs when an interface changes from blocking state, okay, to a forwarding state, right? Of course, we were talking about listening and learning or what have you in the past, right? Early in the chapter, right? So this is the delay for that process that affects the process that occurs when an interface is changing from a blocking state to a forwarding state, right? A port that stays in an interim listening state and then an interim learning state, okay, 15 seconds each, for the number of seconds defined by that forward delay timer, okay? These are all the timers that manage spanning tree convergence, okay? All right. Hopefully that makes sense. Within Packet Tracer, please test this out, right? And read more about this theory, okay, on page 226, right? They have a great diagram or what have you. Okay. Um, let's talk a little bit more about, you know, those interface states that we've talked about, right? So listening and learning, right? And so I told you guys before, right, that, and let me go ahead and put away my marker, right? I told you guys before, right, that a spanning tree is all about the idea of, one part of spanning tree is about the idea of port roles and port states. Okay, let's talk about the difference, right? Roles, right? Root port, designated port, blocking port, right? Those relate to how the spanning tree analyzes the actual topology, right? After it hears what it needs to do, right? States, right? Port states, forwarding, blocking, right? Tell a switch whether to send or receive frames. Okay, so port roles, right? Those are set, right, on an interface depending on the analyzation of the topology. Port states tell the actual port, right, whether to send or receive frames. Okay, so when spanning tree converges, right, goes through the spanning tree convergence, right, a switch chooses new port roles. That's the first thing that it has to do, right? And then those port roles determine the state, either forwarding or blocking, right? And of course, by default, right, with spanning trees, switches they can go ahead and move um, from a forwarding state to a blocking state and vice versa, right? But it's not that simple. It must take time, right? And we're talking about regular spanning tree. So 802.1d, follow me here, right? It must take extra time using timers to converge, to transition from a blocking state to a forwarding state and forwarding state to a blocking state, right? Here's the funny thing, right? Ports, right? Interfaces can immediately go from a forwarding state to a blocking state, okay? But from a blocking state to a forwarding state, it has to take time to transition, okay? All right. So if there's a port that was blocked, right, and it needs to transition to a forwarding state, right, the switch first needs to put the port through two intermediate states, right? Why? What is the point of why, let's say something happened to switch two, right? And the ports become, they go from forwarding to blocking, and now those ports need to go from blocking to forwarding. Why does it need to do that? Well, those states, right? And these two states are listening and learning. They have to go through those states to prevent a temporary loop. Okay. So let's talk about listening first. So, listening, right? Just like the blocking state, the interface does not forward frames. The switch removes old, stale, unused MAC address table entries for which no frames are received from each MAC address during this period. These stale MAC address table entries could be the cause of the temporary loops. So does that make sense? Right? The switch, I'm sorry about my phone, guys. So the switch needs time to prune, right? Any old MAC address entries or what have you, so we don't forward something by accident, right? Or cause any loops, right? So again, during this time, during the listening phase, right, which lasts for 15 seconds, it's not going to go ahead and forward frames. It's prepping, it's pruning its old, unused MAC address entries or what have you, and it's clearing it out, right? And it's also not forwarding frames. Okay. The learning state, okay. So interfaces in this state, right? They still do not forward frames, but now it is slowly, right? This is slowly start to learn MAC addresses, right? And this is the next 15 seconds, right? So listening and learning together last a total of 30 seconds, okay? Right? But that forward delay that we spoke about, 15 seconds each, 15 seconds each. And they reference, right, 802.1d listening and learning, okay? All right. So we spoke about that. We spoke about how that works, right? There is a nice table, okay, that is in your book that is on page 228. Okay. Nice little table. You could take a screenshot or what have you. Have it right here, right? It's a good little memory thing that you can practice looking at, right? It tells you the five states, right? If we're talking about 802.1d, the original spanning tree, not RSTP, not per VLAN spanning tree, what have you, right? We have blocking, listening, learning, forwarding, and disabling, right? It tells you, hey, blocking, are we forwarding data frames? No. Um, is it learns MAC address based on receive frames? No, right? Transition to your stable state, stable, right? And this means it's blocking. It is not. It's stable. It's not going back and forth or what have you. Okay, so it is set to blocking. Listening, right? Listening. What's happening? Is it forwarding data frames? No. Is it learns MAC address based on received frames? No, because what did we just talk about? It needs to flush out, right, the MAC address table for unused MAC address entries, right? It needs to clear it out. I just need to do a quick flush, right? Similar to when you go ahead and get your oil change. You need to flush out all the bad oil, okay? Or leftover oil, right? But it is a transitionary state, right? So if we're comparing this to an oil change, right? We it's now not stable, right? The old oil is not there no more. We're transitioning to putting new oil in. So we're in a transitionary state. Learning, right? So now we've changed the oil, right? My analogy, right? Now we've changed the oil. We're putting the cap back on, right? Once we put the cap back on, right? We have finished the listening state. That's 15 seconds, right? So now moving to the learning state, right? We're going to go ahead and now fill the car back up with oil. We put the screw back on the bottom, right, of the oil pan, and now we can go ahead up to the top of the car and start putting oil inside of it, right? This is similar to the learning phase. The learning, it's not actually forwarding data frames yet, right? But it is learning MAC addresses based on received frames, still in the transitionary state. Okay, right? So similar to the oil change, right? Once we finish it and we complete it, boom, we go ahead and put the top back on. We finish the oil change. We start the car. Boom. Now we can move forward. Similar to spanning tree, it is that port is in a forwarding state. We now can forward data frames. We can learn MAC addresses based on received frames. And now it is stable, right? Because now it is doing its primary role, which is forwarding frames. Okay. Does that make sense? So with that, right, I want you guys to again go back to chapter 9, review. This next section that we're going to do, we're going to go ahead and cover RSTP, right? We're going to move from 802.1d to go ahead and 802.1w. Okay. All right, guys. You guys have a great day. I will see you guys Sunday.